Hey guys, welcome back, I guess. Okay, so basically the final function that I use in the overall control code is this points A to B function. And what this is doing is taking 2 points, so point 1 and point 2, so A and B. Again, just a straightforward row vector describing a coordinate, X and Y, and taking a resolution as well, okay? And what this is doing is basically, so if you have 2 points, and based on the resolution, it will divide it up into smaller segments. So say if you have A to B and a resolution of 4, you're going to end up having 5 points. So basically you're dividing up into 4 segments. So there's one segment, there's a second segment, third segment, fourth segment. Okay. Now the reason for this function is basically if you're trying to move in straight lines, really what you can do is move in smaller arcs, okay, and you're going to basically look as if you're moving in a reasonably straight line, rather than doing one big arc, okay. So that's the reason for this function. So basically, if you have to move from point 1 to point 2, how about you move in a move from point 1 to somewhere kind of going towards point 2, but not quite point 2 in a small arc, and just to keep doing small arcs until you reach point 2. That's what this thing is doing. So it's basically splitting down point A to point B into small segments, as I said before. Okay, so to start that off, what I'm doing is basically this code you won't have to change, but I just want you to understand how it works. Okay, but yeah, the basis is that you throw in your 2 points that you're trying to move between, and then a resolution that basically the number of segments you want it to be broken up into. Okay, and if you throw in just a segment of resolution of 1, it simply spits back those 2. Okay, so the first thing I do, again, you don't have to understand this greatly, so if you get confused, get lost, don't worry about it too much. But if you do get lost or confused, just let me know, and I'll try and sort you out. Okay, so points equals zeros, resolution plus 1, comma 2. So what this is doing is basically, if I call it down here, you'll see resolution. Let's say our resolution is 4. Okay, and then if we call points to see what it is, basically all I'm doing is I'm setting 0, so I'm initializing my array of points. Okay, and basically what I'm doing is I'm saying, okay, I've got a resolution of 4, but really I want 4 segments, so that means I need to have 5 sets of points. Okay, and I want it to be a two-dimensional. I want it to have 2 columns and 5 rows. So I'm setting up an array with 5 columns, 2 rows, and each one of those elements will be set to 0. Here, 5 rows, 2 columns. That's all it's doing. So it's just initializing based on the resolution and an array to put values into. It's just a good practice to get into. Okay, first off, points 1, 1. Okay, so this element here, so looking at points, okay, first row, first column, I'm setting that to be A1. Okay, so basically that's the first. So say for example, this is the example here. A is equal to 100, 0. It's going to put 100 in here. Okay, I then say points first row, second column is A2. So basically it's just saying my first row in there is going to be the same as your point A. Okay, the first set of coordinates that you put into this function. I do a few if statements here. Okay, the reason for that is basically, so if B1, okay, so if the first element of B1, the x coordinate of B and the x coordinate of Y, if you subtract those and they're equal to 0, that means you've got a vertical line. Okay, and so I then do a similar thing. If you subtract your y coordinates and they're equal to 0, then you've got a horizontal line. Okay, else you've got some sort of linear line in there. The reason for I have to do these if statements is basically so I don't get a divide by 0. Otherwise, basically MATLAB will spit the bananas at you and go, what the hell is going on? Okay, So to go through it, first I'm basically going, okay, so if we have a vertical line, so if our x coordinates are in line with each other, we've got some form of vertical line. So I'm saying delta points. So basically, this is working out, okay, based on the resolution, how far do we need to increment each time? Okay, so we go our y2, okay, so y2 minus y1, or our second y minus our first y, divided by the resolution. So that's going to tell us how much we need to move up each time. And then I do a for loop. So from starting at the 2, okay, the reason I start at 2 is because I want to start filling from the second row and not the first row, up until our resolution, points n, so basically points, okay, so depending on the nth row, so we start at 2, our first element, so the first column, or our x, is just going to be equal to b1, or a1 in this case, it doesn't matter, either one. And then we go points, okay, so our nth element, our nth row, and our second column, so our y in our nth point, is going to be a2, okay, so we're starting down the bottom, plus n minus 1 times delta. So what that's doing is basically, okay, so we're going to, if n is starting at 2, we got a minus 1, so, and then we just add on whatever, how much we want to move up. And then as n clocks around, basically it's going to be 2 times that, so go up 2 lots based on a2 and so forth. So it's just adding up a number of segments up until you get to your final resolution, your final point. And then it just goes, okay, so points, resolution plus 1, okay, so basically the final point, the final row in your thing, okay, and the first element is going to be equal to b1, okay, so the x coordinate that for your second point, and then this one should be the y coordinate of your second point. Okay, so that's for a vertical line. You're doing a similar thing for a horizontal line, so if the y coordinates are in line, or if they're equal to 0, then you say your resolution, then your delta point, so how much you're going to move across each time, is going to be x2 minus x1 divided by resolution. And then you do a similar thing with your a for loop, except this time you're incrementing the x coordinate each time, and you don't, and just the y element always stays the same because they're always in line. Okay. Again, you don't have to worry too much if you don't understand this code, because you don't need to change it. But I'm just going through it just so you kind of might understand roughly what's going on. And then you set the last point in your element to be equal to b. Okay. And then basically our final statement, basically if it is a linear line, so we won't get any divide by zeros like we would in these two cases, especially in this case here. So you work out your slope, m, so we're just doing a simple y equals mx plus c. Okay, so your slope is y2 minus y1 on x1 minus x2 minus x1, sorry. And so that's going to work out your slope. And then c is simply a2 minus your slope times a1, okay? So your slope and your y-intercept, and you say delta x equals b1, so x2 minus x1 divided by the resolution, okay? And then you do a similar thing for the linear line, and you notice that this is very similar to what we had up here. Well, it's the exact same, just kind of a bit different. Okay, so your delta x is that based on your resolution, and basically you take and then you just apply. So this is basically y equals m times x. So we worked out x there. We go y equals m times x plus c. Okay, so we're just basically calculating out our x for the next coordinate, and it's putting that into y equals mx plus c, and you spit out your y. Okay, and then basically you go, and then you finalize by saying the final point in your array should be x, your second x that you initialized, bx and by, okay, in the final thing. Okay, so it gives you so that's how it works as such. You can have a look through it if you want, but again, you don't have to change it. To give you a bit of an example of what it is, let's say a equals 100, 0, okay, and b equals 100, 100. So you notice that this one, they've got the same x coordinate, so it should be a vertical line, okay? And so if we then call points A to B, A, B, let's say resolution of 3, no, let's say 4, because otherwise it'll give us recurring decimals, okay? So you notice that basically, because it is a vertical line, our x coordinate stays the same, okay? And then you notice our y coordinate, okay, so that's our point A, our original point, 100, 0. That's our final point. And you notice that basically it's going up in increments of 25, okay? Which makes sense. So if you divide 100 by 4, you're going to get an increment of 25. And so that would get us from 0 to 100 within 4 segments, okay? Again, let's say we change B to equal 200, 0. So this time our y coordinates are the same, but we have a displacement of 100 in the x. Okay, so points A to B, A, comma B. Okay. Oh, didn't define the resolution. Again, let's just define the resolution of 4, because it's a nice easy one. Okay, you notice that the y stays the same, so it's just a horizontal line, so our y should stay the same. And again, you notice that we're going up in increments of 25 because the displacement is 100. Okay, so 200 minus 100 is 100. And then dividing by 4, you get, based on our resolution that we want 4 segments, you get 25. And so you start at 100 and you end at 200. Okay? And then if you just put in some random ones, so A equals 150 to 75, and B equals 200 and then 20. Okay, and we call points A to B, and we go A, comma B. Oh damn, keep forgetting to do the resolution. Let's just put in the resolution 4 again. You notice you get these increments. Okay, so in this case we're in our x coordinate, we're incrementing by 12.5. Again, it makes sense. 200 minus by 150 is 50. Dividing by 4, you get 12.5 increments. Okay, and in this case, you've got 75 minus 20 is a difference of 55, and dividing by 4, what do we have? A 14.75 difference or something like that. Okay, and you notice that it's actually it's decrementing there as such. Okay, so that's how that function works. Again, you don't really need to understand it. But if you do have questions about it, just let us know and I'll try and sort you out. I just wanted you to be aware that basically it spits out this array, okay? So it doesn't spit out individual like vectors, it just spits out a whole array where each row corresponds to a new point on that line that you're trying to create, okay? And then that the resolution changes the number of segments. That's really what they're the two main things that you need to know about this one. Okay, so that's the 3 functions covered. So the next video will be on the actual control of the entire robot using these 3 functions. Okay, so I'll see you for now and catch you soon.